Assalamu alaikum, my dear students. Welcome to your chemistry second paper class of standard 11. Today, I will discuss about Avogadro's law. That is, equal volumes of gases at the same temperature and pressure contain the same number of molecules. That means, volume is directly proportional to the number of moles. The volume increases as the number of mole increases. It doesn't depend on the size or the masses of molecules. So, volume V is directly proportional with amount of gas, that is in mole, where V is the volume and N is the number of moles. So we can write V by N equal to K, where K is a proportionally constant. And for considering more gaseous samples, we can write V1 by N1 equal to V2 by N2. This is actually the mathematical expression of Avogadro's law. Now, experimental proof. What I have said, volume is directly proportional with moles. Follow here. Previously, here the amount of gaseous substance is 1 mole, and where the volume of 1 mole gas is 22.4 liter at 1 atmospheric pressure, and temperature is also constant here. But when the amount of gas is increased by adding, where the amount of gas is 2 mole, then volume becomes 44.8, that is double of previous volume, and pressure is constant here. So from this experiment, it is clearly proved that the statement of Avogadro's is totally correct. That means volume is directly proportional with number of mole of gas. Also, Avogadro said that the same volume of all gases contains same number of molecules. That means here this is the hydrogen balloon, nitrogen balloon and oxygen balloon. The balloons all have the same volume. This means they contain the same number of molecules. That means he also said that the molar volume of all gases at standard temperature and pressure is same, and also 1 mole of any gas at this temperature and pressure, they contain same number of molecules also, and this number is fixed, and this is 6.02 into 10 to the power 23, which is called Avogadro's number, showing honor of him, Amadeus Avogadro. So this specific number containing by 1 mole substance at standard temperature and pressure, this number is called Avogadro's number. Follow this speech said by Amadeus Avogadro. I didn't discover it. It's just named after me. What a speech is that? What a great invention, this number by him. For this, he still now he is familiar to us and he is famous to us. Now we will know about concept of mole and molar volume. What is mole? Already you have knowledge about this mole and molar volume, because in standard 10, that is in previous class, you have gathered concept about this mole and molar volume. So once again I want to review this. Mole, the amount of chemical substance that contains as many as the Avogadro number of molecules, atoms or ions is called the mole of that substance. That means Avogadro's number of molecules, atoms or ions containing amount of chemical substance is called actually mole, and the expression of atomic mass of atoms or molecular mass of molecules in gram unit is called 1 mole of that substance. For example, 44 gram of carbon dioxide molecules. We know that the molecular mass of carbon dioxide is 44. So if we expressed in gram, so this 44 gram will be 1 mole of carbon dioxide molecules. And 1 mole carbon dioxide molecules contains Avogadro's number of carbon dioxide molecules. So this is very clear how mole is related with the number of Avogadro's number of molecules and gram molecular mass. Now, molar volume. The volume of 1 mole gas at STP is called molar volume. The volume of 1 mole gas at standard temperature and pressure, that is 0 degree centigrade and atmospheric pressure, is called molar volume. And you know that this volume is fixed. So at STP, where temperature is 0 degree centigrade and pressure is 1 atmospheric pressure or 760 millimeter of mercury pressure, molar volume is what? 22.4 liter. This is fixed. This is same for any gas, or 1 mole of any gas. At SATP, standard ambient temperature and pressure, where temperature is considered 25 degree centigrade and pressure is same as before, 1 atmosphere pressure. In that time, molar volume will be 24.789 liter. And at 20 degree centigrade temperature and 1 atmospheric pressure, molar volume is 24.04 liter. So you have to just remember the molar volume, then you can directly putting this value and solve your problems. Now I will discuss some problems related with Avogadro's number. For example, what is the mass of 1 methane molecule? How can we solve? We know that 1 mole methane means 16 gram, because there is you have to determine mass. So 1 mole methane equal to 16 gram, mass will be related. So the mass of Avogadro's number of methane molecule is 16 gram. So the mass of 1 molecule is 16 divided by Avogadro's number. So very easy, you can solve this problem. Just you have to understand the math which is given here and what we have to determine here. Follow the next math. How many carbon dioxide molecules are there in 1 gram carbon dioxide? We know that 1 mole carbon dioxide equal to 44 gram. So for in 44 gram carbon dioxide and number of molecule present, Avogadro's number in 1 gram carbon dioxide, how many we can easily determine. Follow the another math. Determine the number of hydrogen and oxygen atoms in 1 mole water. This is little bit different. Follow this. 1 mole water contains H2O. Molecular formula of water is H2O. So 1 mole water contains 2 mole hydrogen atoms and 1 mole oxygen atoms. 1 mole oxygen atoms means Avogadro's number of oxygen atoms. So 2 mole hydrogen atoms means 2 into Avogadro's number of hydrogen atoms. So in 1 mole water, Avogadro's number of oxygen atoms is present, and 2 mole, that is 2 into Avogadro's number, the result, multiplication result, that is 1.204 into 10 to the power 24 atoms of hydrogen atoms present. So in this type of math, just you have to know the formula of the mentioned compound correctly, and from the formula you can identify the amount of constituent atoms. Now follow the another math. How many molecules are there in 2 liter methane at STP? Yes, okay, it's very easy, because we know that 1 mole methane at STP is 22.4 liter, and 1 mole methane contains Avogadro's number of molecules. So in 22.4 liter number of molecules present, Avogadro's number, in 1 how many, and in 2 liter how many. So these are simply, you have to solve the problems. What is the volume of 2 gram oxygen gas at STP? It is also so easy, because we know that 1 gram oxygen means 32 grams. So the volume of 32 gram oxygen at STP is 22.4 liter. In 1 how many, and in 2 gram how many. So easily you can solve this problem also. Also, how many hydrogen atoms are there in 5 liter ammonia gas at STP? Follow this. The volume of 1 mole ammonia at STP is 22.4 liter, and 1 mole ammonia contains 3 mole hydrogen atoms. So in 22.4 liter ammonia, number of hydrogen atoms present 3 into Avogadro's number. 1 liter is how many, and 5 liter is how many. So like this way you can easily solve the problem. So my dear students, this math is not so difficult, very easy. Just you have to practice more and more, and a lot of maths related on this Avogadro's number, mole and molar volume in your book. So please practice all the maths, because if you want to skill in maths, you have to increase your practice. You have to practice more. Here just I have kept some maths for your extra practice at home as SW, but this is, you just not do only this maths, also you have to complete all maths present in your book. Then you will be skilled in calculation in less time, and you will be perfect through practicing more and more. So these are for your home practice, and you will send this math as early as possible, if possible by tomorrow, in your group. So today after this, thank you.